Good afternoon, everyone, or good morning, wherever you are. So, for today, I would explain how I went about creating these tables and how I defined the relationship in the table. So, from our last class, I know we were taking through how to create this table from the main facts table, which was what I did. Let me go to the transform data mode. Can you see my screen?
Clearly.
Can you still see my screen?
But we can't see your Power Query
Um,
screen.
okay, I think something went wrong. My screen suddenly went blank.
Oh, sorry about that.
Uh-huh. It's up now. Yeah, can you see my power query now?
It's coming up. Yes, we can see it now.
Yeah. Okay,
Mm.
so what we did, just a quick recap of the last class before diving into it. So from the sales table, I used referenced this time around rather than duplicates. So I used reference and I referenced the main data that was given to us by clicking on this particular one. And then I was able to create it. And then from there, I created the location, the customer table, the product table, then the sales facts table where I had to remove all of the information that I have present in the other tables so that I don't have duplicate data on my sales facts. So I did that. I did that by using the choose column option,
Mm.
the choose column option to choose the ones I needed, and then um, created the ship mode. After I finished that, then I closed and applied. Please let me know if you can still see my screen.
No, we're just seeing your desktop. Okay. Yeah, we can see
Okay.
your Power BI.
Yeah, I'm sorry, I'm using two screens. So
Yeah, yeah, I understand.
okay.
I understand.
So
Yeah.
now, so after creating those tables and then doing the needful, then uh, and after I've applied it, then I come to the model view to do the relationship. So this is the sales fact, and then we've got the different tables. That's the location table, the customer table, the product table, and the ship mode. So what I did was to define the relationship um, of each of these table of each of these smaller table to the main table, that is the dimensional table to the main fact table. So by using both the primary key and foreign key on the sales table. So if you look at it now, my first table is the sales facts table, and then the ship mode is the second table. So I linked it by the key. It should be this. So the ship mode ID is and the ship mode ID then is many to one, and then I saved it.
For the sake of those that are new, Christina, can you explain the meaning
Okay.
of many to one and all of those? Can you explain
Okay.
the meaning of one and
Mhm.
many?
Okay.
Yeah.
Okay, so to explain that, we call it cardinality, and then there
Yes.
are, I think, three or four of them: many to one, or one to many to many, and then one to one. What that means is, for example, if you look at this one to many, that is for this table, one attribute of this table can be found many times on the fact table. Like for example, now if you look at the ship mode, we just have I don't know if I should go back to the transform data to explain this better.
No,
I'm
you
not
don't need to.
sure.
You can
I
do it
don't know.
from
Okay.
from the table view.
From the table view, okay,
Yeah.
okay, that's true. Now, this is the ship mode. We can see that we have just 4 ship mode. That's the standard class, second class, first class, and same day. So if you go to the sales facts table, if you go to the ship mode in the sales facts table, you will see that we have many of these ship mode, like the transactional occurrence of that ship mode is multiple. So that's
Mm.
why we said on the dimension table it has just one occurrence, but on the fact table it has many occurrence because that's the transactional table. As we do the transaction, the table updates on day to day, or depends on how the company is doing it, updates itself. So on this fact table you have that many side of that ship mode. But when you go to the ship mode table, you can only find what's it called, just a single occurrence of that ship mode. So that's
Okay.
the
So,
explanation of
Christiana,
it.
before you go ahead, I have some corrections here.
Okay.
I have some corrections here. But before I
Okay.
even go to the corrections, I quickly want to put some more. Uh, I really want to throw more light on the cardinality you just explained, the 4 types of relationship. Before we go into that, now there is the many side of things and there's a one side of thing of things. Now, if you look at the fact table, the sales table is a transactional table. It means that all the buying and selling and everything is happening on the sales table. So it records all transactions at a very, at the lowest granular level, which is the date by day. This is on a day by day level, right? It's not like an aggregated one that you only see at a month level or at a week level or whatever dates hierarchy that we are using. But in this is very granular, right? It shows day by day. Now, all the transactions, that means the order date, who bought the product, who sold the product, what ship mode did they use to ship the product out, uh, at what date did the transaction happened, everything that's to do with transaction is what you will see on the sales table. And the ship mode table is a dimension table that just talks about a business entity, right? So the ship mode is the business entity. It talks about the different ways that the products are being shipped, right? We have product that shows a list of all the products that we sell in the organization. We have location. The location can be either, so the location is it depends, right? The location can be either locations that is based on where the customers that we are dealing with, where they live, and it might also be location based on where the business is operating from. So it's always good to understand the business context and business entities very well, because that will help our data interpretation. And you see another table called customers, and that one has a unique list of all our customers. Uh, you know, you see with their IDs and other descriptive attributes about the customer. You see on the customers table, right? Okay, now there is when we say one cardinality, what does that even mean? So one means that the major key on that table, which is used to connect to another table, has a unique list. It means that, for example, in ship mode ID, in ship mode table, there is that uniqueness there. One ship mode ID is not repeating several times. That's why you say the one. Let's say we have 200 lists of ship mode, and one of the IDs now repeats. We now find one of the IDs that has duplicates, right? It means that it will not be one cardinality again. It is going to be many, because one of the IDs has now repeated itself. Do you understand? Or is showing multiple times. Even if it's just one occurrence that happened, that duplicate happened, it will not be one cardinality again. But the moment all the lists, all the IDs that are used to connect to another table is showing one, right? And it is a dimension table, and it is the primary key for that table, then you will see one cardinality there. Now, for sales table also, because in a normal sales environment, one particular ship mode cannot be used only once, and that will be the end of it, right? So you will see um, that many times one ship mode will appear several times because of the frequency that particular ship mode was used in delivering the product. That's why you will see the star symbol showing that it's many cardinality when it comes to this fact table. So oftentimes that is the most common thing that you will see. That now it does not mean that on the fact table at a particular point in time, also possible that you have the one cardinality too. Aslan, can you tell me, or what do you think? When can that happen? When on the sales table too, instead of seeing many cardinality, you are only seeing one.
In the sales table?
Yes.
Um, let me see.
What does that imply if we see only one cardinality on the sales table instead of many?
When it's the only one, that will have only one entry that you cannot be
That means
duplicated, right?
between ship mode and sales, you are seeing one to one instead of one to many.
Okay, so one to many sales, it means that it's a unique value, and many in the other table, right?
In ship mode, you mean?
Yeah,
Okay.
you have, in this case, the cardinality is one to many, one chip mode to many sales fact.
Mm-hmm.
That was what we were talking about. We will have
Yeah.
one
So
entry because
yes. So and I
one
asked
entry
that
ship
in case we now see one to one, we also see one on the sales fact. What does that imply?
that will be one entry in the table ship mode and one entry in the sales fact table.
Okay, thank you. Correct. So it means that each ship mode only appear once also in the sales facts. That is the implication, right? That is the implication of having one to one. It means that on the transactional side, all the not might not be all per se, but it means that there's no ship mode that appears more than once, right? And also on the other side, the ship mode. Sorry about the little noise you are hearing in the background. It's the train is passing beside my house, so that's why the noise. Sorry about that. Okay, guys. So yeah, so you can see that when you are doing your data modeling, you can see one to one, even in between dimension and fact, it can happen. But when that happens, you already know the implication that, oh, what is going on is that probably few or all the dimensions, all the uh um which the dimension, the unique list, the dimensions also appear to be unique on the transactional side of things too, right? Okay, so I want to state that. And I saw that Christina, on your sales table, you still have ship mode inside your sales table. Why? That's not what I taught you guys, and that's not what Astra taught you guys. When you are building a star schema, what did he tell you about star schema? The only thing that will represent your dimensions in the fact table is their keys. So when you have ship mode and ship mode ID inside ship mode table, and you still have the same thing inside of your sales table, then it's not really ideal. It's not an ideal star schema structure. What you should have is for all the dimensions, location, customer, product, ship mode. The only thing that should represent them in your fact is their IDs. But I still see customer ID, I still see customer name. It's like we are repeating the same thing. The customer name already exists inside of customer table. You should not see customer name there again inside the sales fact. What you should see inside of your uh, sales facts, right, should only be customer ID, because every other descriptive attribute about the customer already exists inside the customer table. So what you are doing now will be causing redundancy because you are repeating the same information on different tables. Do you understand what that implies,
Yes.
Christina? So you go back
Yes.
to your transform table now and make those corrections before we can go ahead. That's why I always tell everyone that if you're in a class and things are not clear to you, please ask questions so that you get clarity. Do you understand what we are doing, Aslan?
No, not really.
Do you know that in the ship mode table, we already have all the information about ship mode, right?
Right.
Now, in the sales table, we should not have all the information about ship mode again, since we already have that inside the ship mode table. So the only thing that should represent ship mode here is just the ship mode ID. Do you understand what I'm saying now, Aslan?
Okay. Yeah.
And that should also pertains to every other dimension table too. The only thing that should represent that dimension is just the IDs inside of the transactional table, which is the sales facts. So when you have customer ID inside customer table and you have customer name and you have other customer information inside the customer table, you should not repeat the same thing inside the sales table. Only thing you should have inside the sales table is the customer ID. So when you now want to look for, oh, who is the customer that bought that has the highest sales? Now give us the highest sales. You can now bring that from the customer table and bring the sales measure from where? From the sales fact table. So that's why you will see that the dimension table stores the unique IDs of each dimension and the descriptive attributes of that dimension. Like, for example, customer name, first name, last name, customer gender, customer location. Those are descriptive attributes about the customer. Is it clear to you now, Christiana and Aslan?
Yes, sister.
Okay. Is it clear to you, Aslan? Okay.
Yes. Yes. Mhm.
Okay. So please correct, make sure that all the dimensions, the only thing that represents them here is just what? Is just their IDs. That's the structure of a star schema. Whether it's a star schema or it's a snowflake schema, I will still explain them in depth to you guys so you understand it. Then we need to quickly move to measures. We'll do some very simple measures. Then I will explain some things to you on measures. You might not be able to finish them in the bootcamp. This bootcamp is just meant to introduce you guys to Power BI. Then you'll now be joining make sure you are joining all the webinars that we'll be doing monthly. That's where you're going to learn a lot of things. So in your new table now, do we have customer ID? Confirm that. Do we have location ID? All the dimension, make sure that your IDs are there.
Yeah, customer approval.
Product ID is there, customer ID is there. Okay. Do you have location ID
Yes. And shipment.
and ship mode ID? Which one again? Did we miss anything out?
No.
Is there any other column there that is a discrete attribute of a dimension that is not supposed to be here?
I do not think.
Then why are you using remove other columns instead of, okay, remove other columns means that you are choosing, not deleting.
Yes.
Okay, perfect. Nice. Then you can close and load now. Close and apply. Okay, maybe some few seconds to load. Yeah. Okay, good. Now, I also see that some of your relationships, some are showing straight line and some of these are showing dotted line. Do you know what that means?
Yes.
Dotted line sometimes means inactive relationship. Now, double click on the line between ship mode and sales facts. You see that it's not active, it's not an active relationship. So we have what is called active and inactive relationship. And there are different reasons why we usually have inactive relationship sometimes, which I will say I'm still going to explain by the time we get to what is called role-playing dimension. Role-playing dimension. And I'll give you guys some assignments. You are going to read a lot. You are going to be reading a lot of things, right, in this class. Because a lot of things we can't really touch base. If you want to start doing Power BI, we can do Power BI for a whole year. I'm telling you, because Power BI is so big. Power BI is wide. There's a lot of things inside of Power BI. So you guys will still need to do some kind of personal reading. I'll give you some textbooks. I'll give you some materials. I will share some links with you. I will share some videos with you to also watch that really help your knowledge, right? Okay. So if you look at this now, the reason why it's showing you a dotted line is because there is no active. It means that it's going to really affect your analysis, right? Because there's no active relationship between the two tables that you are connecting to each other. So to make it active, you will see that portion that says make this relationship active. You can check box that. Yes. Now it means that we are using ship mode to filter the ship mode table to filter the information inside the sales facts. Let me explain it again. Now, before I explain, press save now. Press save, and you will still come back here. I will show you something, guys. Can you spread your tables very well? Like they are too close to each other. Can you spread them? Aha, yes, exactly. Spread them so they become exactly. Thank you. Now you will see that by the time we made that relationship active, it has now changed from a dotted line now to a straight line. Now you see that there's something like a direction logo that is showing direction towards the sales facts. Have you? Yeah, exactly. Exactly. That direction logo. I'm going to explain what it means to you. Now, what it means is that filter will happen from the ship mode down to the sales part. It means that I can use the information inside the ship mode table to filter the transactional sales fact table. Now, it means that, for example, in my charts, I can have all the ship mode in a column chart, and any measure that comes from the sales fact, maybe I want to say total sales, total profits, blah, blah, blah. I'm going to be able to do that because of the active relationship between them. And because the ship mode table is the one that will be filtering the sales fact. Now, in the normal sense, or in the normal way, the ship mode table is going to be the one that will be filtering the sales fact. All the dimension tables, they will be the one filtering, because it's like I have a list of customers. I have 20 customers in my customer base, and I want to be able to see the performance of these customers, how they are performing in terms of sales, right? Where will I see that? When I'm looking for the performance metrics, sales, profits, the frequency at which they buy, the quantity they buy, blah, blah, blah. I will see all of that inside the sales facts, right? Because that's where the transaction happens. But my customer table will have a list of all registered customers that I have, or all my onboarded customers. Do you understand what I'm saying now? Now, that's why I'm saying that the dimensional tables will be filtering, because you can bring out that list, right, and put it on one side, and bring out your sales measure, sales calculation. You can bring that also on another side and bring the two together. Now, what that means is that the information inside the dimensional tables are mostly static most times. They are like, it's only when we add new customers that you will see new customer information there. A new customer added a new ID, and some also, and we also register their descriptive attribute also will be on that table. Now, that doesn't really get updates from time to time like the fact table. If we have 20 customers, by the time we bring in calculation from the sales facts, that's when we will now know that, oh, out of all the 20 customers that we have in our company that are registered with us, only 15 out of them are actually buying from us. The other 5 are inactive customers. They are not buying at all. Although they are registered in the company, they are registered as our customer. We onboarded them, or they signed up. They signed up on our application. They put in all their information there at all, but they have not transacted with us before. How will I know that? It's because of the connection between the customer table and the sales fact table. Because the customer table is filtering the transactional information going on inside of the sales facts. Does it make sense to us, guys?
Yes.
Does it make sense to us? Does it make sense to us? Okay, good. Thank you.
Mm.
So you need to make sure that all your relationship are what? They are active. So you see that even customer and sales part is not active. So adjust that also. It's not active. Now, double click on that line again. I want to show you guys something. I want to show you guys something. When that one is as double click on the line again. So what I was telling you guys the other time, you will see cross filter direction is single, right? Look at the other option that is there. Is both. Now you will see single and both. Now, what does that both mean? It means that the sales table can also filter information inside it. If you put it on both, it means that when it was single direction, it means that the dimension table can filter the fact table. But when we put it on both, what that means is that the two can filter each other. But that is not ideal because that will, number one, affect the performance of your reports. Number two is that it doesn't even make any sense, right? To have both filter direction, right? It doesn't make any sense for like in a star schema structure because and that might even cause some kind of complications that might bring. So put it on both and let's see. You'll see how it's going to appear if you put it on both. So sometimes we also use this both when we are trying to do some kind of what we call row level security, which I don't know if we are going to be able to cover that before the end of the boot camp, but let's see how it goes. So click on save. Click on save. So what you will see now is this. The logo was showing direction towards the fact now, right? By the time you put it on both, it will show direction to both sides. You see now, it's showing direction to the facts and it's also showing direction to the what? To the dimension. So you see that it's showing direction. That means that the two can filter each other. But I don't want to bore you guys with this for now. We are still going to look at maybe some use cases where we can have both filter direction. So go and change it back to single filter direction. Change it and save. Now location ID to location ID. Single direction active relationship. You can save now.
Done.
Okay, good. Now that we have all our tables connected to, can you move the sales fact table to the middle? It's still not in the middle yet. Exactly. Now, the reason why we call this kind of structure a star schema is because it has a star-like what? Structure. In star, you have the edges and you have the middle part will be there. So the sales part is like the middle part of the star, and the edges, the pointers of the star is all the dimension tables that you are seeing here. So you see all the dimension tables connecting to the fact in the middle. So that's what we call a star schema. Now, on the other side, you also have a snowflake schema, right? Now, the snowflake schema is like an extension of the star schema. Now, you know that in a star schema, all the dimensions will connect directly to the what? To the facts, right? All the dimensions will do what? Will connect directly to what? The facts. Now, in a snowflake schema, sorry, that's for star schema. In a snowflake schema, you will see that you have an hierarchy of the dimensions. So let me give you an example. You can find yourself in a situation whereby the location table will be linked to the customer table and not to the sales facts. And I will explain that. Because after the customer's information has been is on the customer table, location will now link to the customer, so to tell you where each customers are located, where they are living, right? Where they reside. So you now see the location table linking to the customer. So it's not like sales linking to customer linking to location. Let me give you another example. You can have three categories hierarchy in terms of products. We can have product category, we can have product subcategory, and we can have the product itself. So when you now see product table, you will now see product table linking to product subcategory table. Now, product subcategory table will now be linking to the product category table, right? So when you have linkage between two, like dimension tables are connected to each other, that's when we now call that a snowflake schema, because you see an hierarchy in terms of your dimensions. Yeah, this you can break down your dimensions to, you are breaking it down. We call it normalization. It means that you are breaking that dimension table down to different hierarchies, right? Or another example that we can talk about. Let's say, for example, you have in a warehouse, right? In a warehouse, right? You have warehouse managers, right? So let's say, for example, you see a warehouse table that has a list of all the warehouses: warehouse A, warehouse B, warehouse C, warehouse D. You can now have another list of managers that will now link up to the warehouse, to the list of warehouse. It is, we will now see, oh, maybe two, three managers in a warehouse, right? Now, under each manager also, you can also have inventory clerks. You can have storekeepers that will be reporting to different managers. And you will now see that hierarchy, right? There are still dimensions, right? But there's the dimension now has hierarchy, right? Maybe the lowest of the hierarchy is the storekeeper or the inventory clerk, or whatever you guys will call them. And from the inventory clerk, what do you see? You see the different warehouse managers, or you see, or some people call them store managers, or whatever you guys want to call them. And you also see the warehouse itself. So look at that kind of hierarchy. Now, under each, let's say, depending on the organizational structure, under each of the warehouse also, you can have trucks that are assigned to each warehouse. So you see another table called trucks that are linking to the warehouse. Yeah, right. Under the different trucks, so you can have another sub dimension that will be probably like drivers, and you see different drivers that are attached to different trucks. Do you understand what a snowflake schema is, guys? Does it make sense to you?
Kind of.
Sorry,
Yes.
Aslan, is it clear?
Yeah, kind of. I mean, yeah, I will look for more examples. I
So
would prefer see something visually, just like we are seeing
yeah,
in the star scheme.
the star schema. Okay, okay. We don't have the data now for that, but probably I would look for a data that has that we can use as an example,
Okay.
right? Before the class will end. So, but now the thing here is that Power BI is optimized for a star schema. Do you understand what I'm saying now? Power BI is what? Optimized for star schema. It means that Power BI works well with star schema than Snowflake schema. Do you understand? Having Snowflake schema on your Power BI data model can bring about what we call, what do we call it? Oh, there's a name for it. Uh, like that is, it might affect the optimization of the performance of your report. It might affect how your report is. Well, as a Power BI analyst or developer, whatever you guys call the position, we are always after optimizing optimizing all of our reports in any way possible. And when we say optimizing report, what we mean by optimizing report is that we want something that when we click on refresh, or when we schedule a refresh for our report, we want the refresh to happen as fast as possible. We want the refresh to happen as what? As fast as possible, right? That is optimization. When you query your source, when we say query your source, we do not mean SQL query per se. What we mean by query is that when you build a new chart or you try to write the calculation and you want to showcase the calculation with a visual, you want the result to come out fast as possible. You want calculation to run because it will communicate with the source and will display you a report. Don't worry, we'll talk about formula engine, and what's the other? I forgot the name of the other one. Right? Oh, sorry, give me a minute, guys. I'm coming. Okay. So as I was saying, that sometimes snowflake. So what we usually do when we have a snowflake schema like that is that there's what we call denormalization. We denormalize it back to a star schema. That is, instead of having that hierarchy, we are going to go to our Power Query. And the way we broke down the tables, we are going to make sure that we do what is called merge, right? We'll have one table and we are going to merge other columns from other tables to come and join that table. So we'll have all the information inside one table about that particular business entity or that particular dimension. So instead of breaking down products into product table, category, and subcategory, we will now have all the information about the products, subcategory they belong to, and the category inside one table. We now call that denormalization. We have denormalized it back from its normal state, right? From its normal state, from the state it was, right, back now to what? A denormalized state. So that's why you usually see that in some exams, when you're trying to write your Power BI exam, you might see questions around that will talk about the normalization and normalization. Now, when you were breaking down the tables, right, you had one sales fact table and we're breaking it down to different dimensions, right? That one is normalization. You are normalizing it, you are breaking it down, you are extracting out all the dimensions from the facts. Now, when you now instead of now having different hierarchies to say, oh, product table, product subcategory, the next hierarchy, then we have product category as the next hierarchy. We don't need to do that. We don't do that in star schema. And when you see that kind of structure, what I will advise you to do is, if you don't want complications and you don't want to have optimization issues, because Power BI is well optimized for star schema and not Snowflake, it's better you denormalize it back such that all the information that you broke down will be in just one table. Don't worry, we are going to practicalize it maybe probably next week. We'll come back next week, right? And you are going to be able to break it down, right? And you have all the information in one table. And that will now be the one connecting directly to your sales table, your fact table. Now, before we go ahead, there's still another concept I would like to discuss with you guys. I want you guys to read it. I will give you as an assignment. I want you guys to read about the concept called conformed dimension. Conformed dimension. Now, I'll give you a little intro, and I want you guys to do more research about it, read more about it. You will see the different variations of conformed dimension. Now, what do we mean by conformed dimension? Is a dimension that can connect to the fact table or all the fact tables we have in our data model. So let's say, for example, we have two fact tables. Maybe we have inventory table and we have sales table. Inventory table is what? All the inventory table is to show all the goods that are, that we are buying, that we are bringing to the warehouse, right? All the goods that we are different products that's coming to the warehouse. The inventory table will be recording that. Now, the sales table also will be recording all the sales transaction, right? As we are selling, who is buying the product, where are we delivering to, what ship mode, blah, blah, blah. All the information about this transaction will be on the sales table. Now, if we look at inventory and sales, right? Which of the dimension tables here do you think is common that we can link up with the two? We can relate to the two tables that are common to them. Aslan and Christiana, give me examples of dimension tables that are common to both sales and what's it called? Both sales and inventory.
Product.
Product is a good one. Yes. Aslan, I want to hear your response.
Customer, maybe.
Customer cannot be common to the two. Customer cannot be common to the two. Unless maybe the inventory table is recording the customer that received the product. But you know that most times the sales department will get the product from the inventory guys. So the inventory guys does sometimes it's not their business to know which customer it was delivered to, because the product will be picked up by the sales department. So give me another example. Apart from product, what other dimension is common to inventory and sales? Guys, think about
Can we
it.
say location?
Sorry?
Can we say location?
Well, it depends. It depends. Location can be common to the two. Yes, location is we can say location. So now product and location, okay. What other dimension is common to sales and inventory?
Guess what? If it's not customer, then it will be ship mode.
The ship mode can be different on both sides.
Okay.
Do you understand what I'm saying? Depending on the structure of the organization. So the ship mode to deliver to customer can be different from the ship mode to get the goods inside of the warehouse. Most times it's usually 2 truck for warehouse. And when you are delivering to customers, you are delivering in smaller pieces.
Big.
Aha. It might be through van, it might be through car, it might be through bike, it might be through any other means.
Okay.
Small buses. Aha. So it might not be the same unless we have one dimension table that has ship mode, then that has maybe from the first to the fourth row is the ship mode for inventory, and from the fifth to the 10th row might be the ship mode for customers. Unless we have that, that's when we can have ship mode common to both parts. So another one I'll give you guys that you guys didn't mention is date. Date is a common dimension to both inventory and sales. Date. Now, the other ones that we didn't talk about, customers. In the context of the relationship between inventory and sales, customer is not a confirmed dimension, because the concept of confirmed dimension is that any dimension that we can link to all the fact tables that we have in our model. And in the example of inventory and sales, customer and ship mode might not be confirmed dimension, but dates, products are good examples of confirmed, because the two can link to what? Both inventory and sales. So any dimension that can be linked up to all our fact tables in our data model are called confirmed dimension. Do you understand what I'm saying now, guys?
Yeah, is it the one now they now have to use a bridge table?
It's not, this is not, I want you to get the concept clear. This is not about bridge table now.
No, I just want to try and link it. Maybe I will
No,
understand.
don't link it with bridge table.
Okay.
Just understand the concept. is a concept, right? When we say conform dimension, it means that I've given you an example: sales and inventory. What are the common dimensions that are common to the two? You mentioned products and we mentioned dates. A very good example. Customer is not common to the two because customer will be related more to sales and not to inventory. Do you understand what I'm saying? So any dimension table that we can connect to all the fact table in our data model is called conform dimension. The ones that cannot relate to the two, the fact table at the same time, is not a conform dimension. It's still a dimension table, don't get me wrong, but there's conform dimension, and there are the ones that are not conformed. Do you understand the concept now?
Yeah, we'll read about it more.
That's why you need to read about it. Exactly. That's what I was expecting you to say. Aslan, does it make sense to you? Conform
Yeah.
dimensions.
Yeah.
See, let me tell you something, guys. For us to really grow, or for you to grow in this career, you cannot just rely on what we are teaching you in class alone. You have to do the extra work by going after the class and reading up stuff on your own. And if it's not clear to you, you can come to the WhatsApp group and ask, and we are available to answer you. That's why we are a community, right? To help each other. Okay, guys. So we can stop here for today. By the time we come next week, we are going to start writing DAX. So prepare for DAX. Any questions?
You may want to stop recording. This is personal. I don't know if you have maybe like 5-10 minutes. It's on Power BI, but it's not relating to the class.
I don't think I have extra minutes because I have
Extra
another class to
minutes.
prepare for.
Another class. Okay. No
Unless we
problem.
can link up before the next class.
Okay, no problem then.
Yes.
All right.
Thank you.
Yeah.
Any other person, any other question? Okay, there are no questions, guys. Okay, Aslan.
I know. How good? How good? Thank you.
Okay, if there are no questions, guys, let's meet up again next week, Saturday. Thank you, guys.
All right.
Bye.
Thank you. Thank you,
Bye.
everyone.
Thank
Bye.
you.
Bye.